Hello and welcome student to the lecture number 34. Today we will discuss one theory regarding deformation of a body due to force acting on it, and we will discuss some numericals. So let us start. Deformation of a body due to force acting on it. Now what is deformation? Deformation means to increase or to decrease the length of some body. Let us consider a body subjected to a tensile stress. As per yesterday's lecture, if a body is subjected to pull force from both the ends, then it is known as the body subjected to tensile stress. Now, let us start some notations. For example, what is P? P is equal to load or force acting on the body. What is L? Length of the body. What is A? Cross-sectional area of the body. What is sigma? Stress induced in the body. What is E? Modulus of elasticity for the material of the body. What is epsilon? Strain. And what is delta L? Deformation of the body. Now what is our target? Our target is to find delta L, means deformation of the body, which means increase or decrease in the length. Now let us start with the formula. As we know that stress sigma is equal to P by A. As per yesterday's formula, strain is also epsilon is equal to sigma by E. Now replace this P by A into second equation, then we will get P by A. It means sigma is equal to P by AE. So this is the final formula for strain. Epsilon is equal to P by A. And we have to find deformation delta L. And what is the formula for delta L? It is equal to epsilon into L. Replace this value of epsilon over here. It means sigma L by E. And sigma is again P by A over here. So it will be PL by AE. So finally delta L is equal to PL by AE. This is our formula, as sigma is equal to P by A. So finally this will give the deformation of a body subjected to tensile stress. Delta L is equal to PL upon A. Delta L means change in length, increase or decrease. It will be in mm. P means force, it must be in Newton. L means original length, which must be in mm. A means cross-sectional area, depends on the shape of the subject. And E is equal to modulus of elasticity, which unit is Newton per mm square. So now, students, let us start with some examples. So now let us start with example number 1. What is given in the data is that a steel rod 1 meter long. So concentrate on the data. Length L is equal to 1 meter, which means 1 into 10 raised to 3 mm. And 20 mm cross 20 mm in cross section. So cross sectional area A is equal to 20 cross 20, which is 400 mm square. Is subjected to tensile force of 40 kilonewton. So tensile force P is equal to 40 kilonewton, means 40 into 10 raised to 3 Newton. What we have to determine? We have to determine the elongation of the rod, means delta L. If modulus of elasticity E is given to you for the rod material is 200 gigapascal. Now concentrate. E is equal to 200 gigapascal means 200 into 10 raised to 3 Newton per mm square. So must remember this. Gigapascal must be converted into Newton per mm square. So whenever gigapascal is given, just multiply it by 10 raised to 3 and you will get the answer in Newton per mm square. So let us start with the formula. Very simple example. Delta L is equal to PL by A. Just replace the values over here. What is P? P is equal to 40 kilonewton, means 40 into 10 raised to 3. What is length given to you? 1 meter, means 1 into 10 raised to 3 mm. Cross sectional area is 400 and Young's modulus is 200 into 10 raised to 3. Here it is 200. Must note, here it is 200 into 10 raised to 3. So In the calculator, final answer will be 0.5 mm. So this is the final answer. So delta L is equal to 0.5 mm. So this is the elongation of the bar, 0.5 mm for the original length of 1 meter, means 1000 mm. So this type of simple numericals are readily available for your practice. Let us see some another example. Here it is example number 2. What is given in the data? A hollow cylinder 2 meter long. So 2 meter long means length is equal to 2 meter, 2 into 10 raised to 3 mm. Has an outside diameter of 50 mm and inside diameter of 30 mm. So outside diameter capital D is equal to 50 mm, inside diameter small d is equal to 30 mm. Now, if the cylinder is carrying a load of 25 kilonewton, so cylinder is carrying a load P is equal to 25 into 10 raised to 3 Newton. Find the stress in the cylinder. So first of all we have to find stress. Also find the deformation of the cylinders. So what we have to find delta L. If the value of modulus of elasticity for the material is 100 gigapascal. So again it is 100 into 10 raised to 3 Newton per mm square. So this is the data. Now first of all let us start with the stress in the cylinder. For the stress we have to find first of all area. So what is the cross section area of the cylinder? The cylinder is hollow because outside and inside diameter are given. So area will be, cross section area will be pi by 4 into capital D square minus small d square, which is equal to pi by 4 into 50 square minus 30 square. That will give you answer 1257 mm square. Moving ahead, what is deformation of the cylinder? We know that delta L is equal to PL by P is given to you 25 into 10 raised to 3 Newton. Length 2 meter means 2 into 10 raised to 3 mm. Area we have calculated 1257 and Young modulus is equal to 100 into 10 raised to 3. So by doing calculation in your calci we will get the answer of deformation as 0.4 mm. So this is the final answer of deformation. Now moving ahead, let us see some another example 2.3. What is given in this? It is given that a load of 5 kilonewton. 5 kilonewton means again 5 into 10 raised to 3 Newton is to be raised with the help of steel wire. So load is to be lifted by steel wire. Find the minimum diameter of steel wire. Okay, we have to find the minimum diameter of steel wire. Suppose it is in mm and it is denoted by D over here. Now it is given that the stress is not to exceed 100 megapascal. So stress sigma is given to you 100 megapascal. Now megapascal itself a Newton per mm square. Must remember this. In the gigapascal we are multiplying by 10 raised to 3. But when it is given in megapascal, value remains as it is. So 100 megapascal itself 100 Newton per mm square. Now we know that stress in the wire. What is the formula for stress? Stress sigma is equal to P by A. Sigma is given to you as 100. Now what is P? 5 into 10 raised to 3 as given in the data. What is cross section area? Pi by 4 d square. So now d square remains unknown. Pi by 4 and 5 into 10 raised to 3 can be solved out with the help of calci. It will give you the answer of 6.366 10 raised to 3. So therefore making subject as a d square is equal to this, then you will get the answer 63.66. By doing the square root you will get d equal to 7.98 approximately equal to 8 mm. So this is the finally diameter of steel wire. 8 mm diameter of wire is required to lift the load of 5000 Newton. So must remember this, 5000 Newton is a tremendous quantity of load which is just lifted by 8 mm diameter of wire. So it is very helpful to understand you for very simple practical problems in day by day use. Let us see some another example. Example 2.4. What is given in this? In an experiment, steel specimen of 13 mm diameter, steel rod of 13 mm diameter was found to elongate 0.2 mm. Elongate means delta L is given to you. So first of all diameter is 13 mm, elongation delta L is equal to 0.2 mm. In a 200 mm gauge length, so length L is equal to 200 mm. when it was subjected to a tensile force of 26.8 kilonewton. So tensile force P is given to you 26.8 kilonewton. If the specimen was tested within the elastic range, what is the value of Young's modulus for the steel specimen? So let us find that E is equal to value of Young's modulus for the steel specimen. A means cross section area, which is pi by 4 d square. By replacing the value of d equal to 13, then you will get the answer of cross section area as 132.73 mm square. Now what we have to calculate? We have to calculate E. So moving on to the formula, we know that delta L is equal to PL upon A. Delta L is given in the example 0.2 mm. P is equal to 26.8. Length is equal to 20. Cross section area is equal to 132.73 and E is remains to be calculated. So by doing solution, 40.38 upon E is the answer. Making subject as E, 40.38 by 0.2, it will give you 201.9 kilonewton per mm square. Now remember this, kilonewton per mm square, it means 201.9 gigapascal. It is reverse, kilo. So by removing kilo, you will subtracting 10 raised to 3, so it will give the answer in gigapascal. So must remember this unit conversions. Just stop this video at regular intervals, go back and check the 4 numericals completed in your mind. So what we have calculated, what we have studied in today's lecture, we have studied one theory. First theory, that is deformation of the object due to tensile stress, and on the base of that we have calculated 4 such numericals. So you have to revise these numericals again and again and be very precise in calculation. In the next lecture we will start some another topic and examples related to that. Thank you very much, students.